Hello everyone, this is the Hesi A Squared Mathematics full review. I took the Hesi twice and I passed both times, and I also have experience taking the Kaplan and the Tees exam. If you're taking the Tees or the Kaplan, you should still follow along with this review. Math is a universal language, and I do recall most of this information is the same. Same on the Kaplan, the Tees, and the Hesi. So still follow along. With that being said, we're going to go ahead and get started. But before we do, I'm going to ask you guys a big, huge favor. Please subscribe to the channel. It really helps me out a lot. I put a lot of time and effort into these videos. I've noticed I'm getting a lot of views, but not a lot of subscribers. So please subscribe. It doesn't cost you anything. Like the video, comment down below, and share this video with another student that you know may be taking a pre-nursing exam. With that being said, let's get started. On the Hesi, you will be provided a scratch paper and pencil as well as a digital calculator. You will be given 50 minutes to complete 55 questions. You will be tested on basic math skills such as fraction, subtraction, addition, division, multiplication problems, decimal and Roman numerals, measurements, percentages, conversions, military time, ratios and proportions, word problems, and algebra. So guys, I just want to clear up, it's important to know the vocabulary, not because you would be tested on each word, but it's important to know because when you're reading these math problems, you will see these terms, and it's important to know because you need to know what you're actually looking for, what is the problem asking you to do, and also how you can find the correct answer. So you won't be tested on what a fraction bar is or anything like that. No. It's good to be familiar with the vocabulary so that you can choose the right answer that's being asked. So an exponent is a number or a symbol placed above or after a symbol indicating the number of times to multiply. For an example, 25 to the second power. So you will have 25 times 25. That 2 is the exponent. An expression is a mathematical sentence containing constants and variables. So an example would be 3x minus 4. So a factor is a number that divides evenly into another number. You may have a question that asks you, what is the factor of such and such and such and such and such? So it's important to know what it means and what it's asking for. A fraction bar is the line between the numerator and the denominator. We know that the numerator is the number that's on top and the denominator is the one at the bottom. So that fraction bar divides them. Improper fraction is where the numerator is greater than or equal to the denominator. For an example, you will have a problem that says 25 over 5. That's an improper fraction because the numerator is greater than the denominator. Next, we have least common denominator, also known as the LCD. This is the smallest multiple that two numbers share. For an example, 3 and 5. 3 multiples of 3 will be 3, 6, 9, 12, 15. Let's stop there. Now we have multiples of 5. 5, 10, 15. We can stop there. As you notice, they both have 15 in common, and that 15 would be the LCD. So a common denominator is when two or more fractions have the same denominator. It's like alike. So an example would be like 1 over 2 and 2 over 2, the common denominators. So a constant is a number that cannot change. It's constant. A denominator is the number that is in the bottom of the fraction, as you see in green, the bottom number. And a digit is any number 0 to 9. So 10 is not a digit. So a dividend is a number being divided. It is underlined in red, guys. So that would be, if we have 9 divided by 27, 27 will be our dividend. And then we have a divisor, which is the number by which the dividend is divided by. So that would be our 9 in this scenario, which is circled in green. So the last of the definitions, we have a remainder. A remainder is a portion of the dividend that is not evenly divisible by the divisor. So in this scenario here, we have 5 divided by 128. Our 3 will be the remainder. That's the number that's left over when you're dividing. Terminating decimal is a decimal that is not continuous. And then we have a variable, which is a letter representing an unknown quantity. We have an example, 3x minus 1, and in this case, x is the variable. And also, sum means total. Okay guys, so for the math section, it's pretty simple. You want to keep in mind you will be given a calculator, so you don't have to do these problems on hand. So yeah, let's keep that in mind, okay? You can do them on hand if you want to, just to make sure that you have actually got the correct answer. But I use the calculator for simple problems like this, and the scratch paper for harder, complicated problems. So the calculator that you will be given on the test will be like a basic calculator, very similar to your phone, or like a dollar calculator you may find at the Family Dollar or something like that. So I'll just go ahead and show you guys how I would plug these numbers in the calculator. So for an example, if I had 12 minus 899, you want to go ahead and put it in 12 minus 8.99. You want to make sure you use a decimal. I didn't use it this time. 12 minus 8.99, that's going to give you 3.01, and that's going to be your answer. So when you're doing the decimals, just be extra careful that you're actually using the decimal placements. If not, you can just do it the old-fashioned way. I'm going to show you guys how to do it the old-fashioned way too, but I'm just showing you how to do it the quicker way. And also knowing your multiplication and your division numbers from grade school would actually help, because you can just look at a problem and be like, oh, 5, you know, you could just, it just jumped out at you. And then we have 23 times 5 is going to give you 115. You can just plug that into the calculator. 23 times 5 is going to give you 115. So that's basically it. For this question here, 6 divided by 672, you would put 672 first, divided by 6, 112. And then if you don't remember to do the bigger number first with these types of problems, always eliminate the answers by doing the opposite operation. So this is a division problem. I would just do a 112, just go through all of the options and multiply it by 6, and whatever number I would get, I would select that particular number. And I hope that makes sense to you guys. So if I didn't know the answer or know how to find the answer, especially with the ratio and the proportions, if I was just stuck, I will go through my options and calculate these numbers with this number here to find this number here. That's what I would do if I didn't have a calculator or didn't have time, or just didn't feel like doing it the long way. So anyway, let's go into some other problems. All right, so I'm going to do 6 divided by 672 the long way by hand. And I'm going to go ahead and erase this stuff right here so I can have room. This is something that I learned. I made an acronym for it's like doing long division where I'm in algebra, or whereas I'm taking statistics. So I write down the steps. That's divide, multiply, subtract, and bring down. DMSB. That's what I do to help me remember. So let's get started. Let's do 6 divided by 6. That's going to give us 1, and then we want to multiply next, and then 1 times 6 is going to give us 6. The next step after we multiply would be subtract. So subtract 6 from 6 is going to give us 0, and then we start over again by bringing down the next number variable. We have 7, so we do it again. 7 goes into 6 how many times? 1 time. Put that 1 there. Next step after we divide, we multiply. So 1 times 6 is going to give us 6. And after we multiply, we have to subtract. Subtract 7 from 6 is going to give us 1. So next we bring down. Bring down what? That 2. And that's going to give us 12. And then we have 12. Our next step is to divide once we start off right now. Divide. 12 divided by 6 is going to give us 2. And then 2 times 6 is going to give us 12. It's going to give us 12 again. And that's going to give us a remainder of 0. And there's nothing else to bring down, so the cycle ends there, and that gives us 112. That's the long way of doing it. But like I said, you don't have to do it that way because we have a calculator and we're pushed for time. Here we have some more basic subtraction and addition problems. So once again, you can plug this into the calculator, but if for some strange reason you don't have access to a calculator, you can just go ahead and do it the old-fashioned way. So as we see, we have 2.61 plus 3.1. I'm going to go ahead and line this up a little bit better because Me personally, I need to see where everything is going. So we just basically add like a regular problem. 6 plus 1, 7. We got 3 plus 2. It's going to give us 5. So our answer is 571. Next we have 12.37 plus 5.00. We just basically do regular addition. It's going to give us what? 517. 1737. Next we have 3.41 times 7. That's going to give us 7 times 1 is 7. 7 times 4 is 28. And 7 times 3 is 21. Plus 2 is going to give us 23. 23.87 is the answer. And then now we have 0.002 times 3.4. And of course they are lined up, so I won't get confused. I'll bring down the 4 times 2 is going to give us 8. 4 times 0 is going to give us 0. 4 times 0 is going to give us 0. And 4 times 0 again is going to give us 0. Now we have 3 times 6 is 3 times 2 is going to give us 6. Make sure you have to skip that space there. It's important. 3 times 0 is 0. 3 times 0 is 0. And 3 times 0 is 0. So now we just add this up. It's going to leave us with 8, 68, and 1, 2, 3 zeros in front of it. So to calculate where you're going to place it, you just count the placements behind the decimals. 1, 2, 3, 4 placements. So basically we start here counting and we move the decimal from 1, 2, 3, 4. So the answer is going to be 0.0068.
Roman numerals. If you guys remember what's on the board before you, you'll be fine for the test. I represents 1, V represents 5, X represents 10, L represents 50, M represents 1,000, C represents 100, and D represents 500. As you can see, I'm writing 5 and 2. So 5 plus 2 is 7. Now I'm going to do another problem where I'm going to write 1 plus 5. Now really, in Roman numerals, if you have a smaller number leading, you need to subtract. So 1 minus 5 is going to give us 4. So anytime you have a smaller number leading before a smaller number before a bigger number, you ought to subtract. And another example would be CD. You would subtract 100 from 500, and that's basically how you write 400 CD. We have another example of that. I'm writing I, which is 1, and X, which is 10. So that's 1 minus 10, which will give us 9.
So when writing larger Roman numerals, there is a viculum or a horizontal line that is written above it. So it's pretty simple. So you guys remember what M stood for? And if you guessed 1,000, you're correct. But with the viculum or the horizontal bar on above it, it indicates 1,000,000. Now we have V. What is V? V is 5. What the viculum on above it, it is 5,000. Y'all see the pattern? We have X, which is 10. 10,000 when that bar is above it. Next we have L. L is 50. If you guessed right. What our viculum, that little horizontal bar, is going to be 50,000. C, C for century, which is 100. What our horizontal bar above it, or line, it would be 100,000. D stands for 500. What our bar above, it is 500,000. All right, so let's do some sample problems. First, we have M, X, and 2. So the first thing you're gonna do is you gotta know what M is. So M is 1,000. It's gonna be plus 1,000 plus X, which is 10, plus 2. And that's gonna give you 10,000 plus, 1,000 plus 1,000 is 2,012. Alright, so next we have LX2, and L is 50, and X is 10, and this will be 2. So 50 plus 10 plus 20, I'm sorry, why did I put 20 there? I don't know. But 50 plus 10 plus 2 is 62. So next we have XCI, or I don't know how to say it, but the X is 10, C is what? 100. I don't know why I need to eat something. Plus, so because the 10 is before the 100 and 100 is more, you have to subtract. So that's gonna give you 10 minus 100 is 90. Plus 1 is going to give you 91. That's going to be the final answer. I hope y'all understand it. If you don't understand it, just leave a comment down below and I'll try to explain it to you the best way I possibly can. So, these are the problems that you will probably see, most likely, on the Hesi. It won't give you something simple. I think I saw something similar to this one. But they won't give you something that's like really simple. They're going to give you the hardest one. And it's probably like, I remember seeing one question. I'll say like 1 or 2 questions on the Hesi. So we have to know what D is. D means 500. That's 10, 20, 30. I'm just going to go ahead and calculate that up just for the sake of space. So we got 30 here. Then we got 5 plus 5 plus 3. And you just basically add that up. So 538. 538. We have MMM, DC, XXI. Alright, same way we do any other problem. Don't be intimidated just because it's long. You just basically need to write it out. M is 1,000 plus 1,000 plus 1,000. I should have just wrote 3. Let me just write 3,000 just in case. So I know this collectively is 3,000. Alright. And our D is going to be 500. And C is 100. 2 X's together would be 20. And then we have that 1. So we just added together. 3,000 plus 500 plus 100 plus 20 plus 1. So that's going to give us with 3,621. That's going to be the answer. Yeah, know that because they won't give you no easy questions. Alright, so C, that's problem. C is 100 plus L, which is 50, plus 5 plus 2. Add it up. 500, I'm sorry, where I get 500 from? 100 plus 50 is 150, 155, 157. It's going to be the final answer.
Now we're going to talk about the metric system and conversions. 1 kilometer equals 1,000 meters. 1 meter equals 100 centimeters. 1 centimeter equals 10 millimeters. 2.54 centimeters equals 1 inch. Next we have 1 mile. 1 mile equals 1,760 yards or 5,280 feet. 1 yard equals 3 feet. 1 foot equals 12 inches.
Volume and capacity. So there were a few questions on the test. It's going to ask you to like convert gallons into quarts. So it's good to know the measurements, not only for the Hesi, but as a nurse, you need to know this stuff. And it doesn't go away, especially in pharmacology. It doesn't go away at all. So it's good to know conversions. Just get a head start, knowing measurements and knowing your metric system. Anyway. So as you can see, guys, I color coordinated everything, and I don't know about you, but I have to color coordinate everything because I'm a visual learner, and coordinating colors helps me to understand better. So I'll explain this in a little bit. So 1 gallon equals 128 ounces, and you need to remember that because I do remember a question on the test that asked about this. I think it was like how much a gallon, how many ounces in a gallon. I remember that. So that's on the test. Anyway, so 1 gallon equals Also 4 quarts, and as you can see, this little chart here, I don't know where this came from, y'all. I'm not the originator of this, but when I tell you it helped me, it has helped me so much to remember what's in a gallon. Okay, so I'll explain this. This big G represents, purple G represents a gallon. So the Q is a quart, and the P's represents pint. And as you can see, everything is color coordinated, so hopefully there's no confusion there. So in a gallon, there are 4 quarts, as you see, and then also in a gallon, there is 2, 4, 6, 8 pints. Okay, 8 pints. So within a quart, there are 2 pints. So hopefully this helps you as well, because when I tell you, it really, really helped me. Like, I'm not really good with measurements like that, so that helped me. Anyway, 1 quart equals 2 pints, as we see here in our little illustration. And then we have 1 pint that equals 2 cups, which is essentially what's in ice cream, like the same measurement in ice cream. So just keep that in mind, because I do remember a question about pints and 2 cups and something about ice cream. So just remember that. And 1 cup equals 8 ounces or 16 tablespoons. 1 ounce equals 30 mLs. This is something that you need to know as a nurse, so just keep that in mind. If it's not on the Hesi, you need to know it. Okay, so, and also 1 ounce equals 2 tablespoons. And 1 tablespoon equals 4 teaspoons. And also it's 15 ml. Weight and mass. 1 kilogram equals 1,000 grams. 1 gram equals 1,000 milligrams. And 1 ton equals 2,000 pounds. 1 pound equals 16 ounces. 2.2 pounds equals 1 kilogram. Now, as far as the Hesi, I do remember seeing 2.2 pounds equals kilogram. I do remember seeing them asking the question about this conversion. This conversion of 1 ton equals 2,000 pounds. I remember seeing this, and I did remember seeing a lot of questions about the kilograms and grams. So know all of this, because, like I said, if you're in nursing, this doesn't
So
go
there's a
away.
technique that students use to help convert certain units to larger or smaller units of measurements, and we do that by keeping in mind a mnemonic King Henry died by drinking chocolate milk, where your K stands for kilo, H stands for hecta, D stands for deca, B stands for your basic units such as meters, liters, and grams, and D stands for deca, C stands for centi, and M stands for milli.
Here's like a more in-depth prefix chart. So screenshot this, you guys.
To further explain what this mnemonic means or what it stands for, we can look at this as a timeline, where your bigger numbers are to the left and your smaller numbers are to the right. And in the middle, you have your basic units, meter, liter, and grams. Now, what that means, it's kind of like a suffix, if you will. And your kilo, hecto, deca, deci, centi, and milli, these are prefixes. So this is like a shortcut, genius way to solve problems like this. So I'll further explain. But before I do, let me just go ahead and elaborate on the suffix or the basic units. So you have a kiloliter. You can have a deciliter. You can have a millimeter. You see what I'm saying? So let's go ahead and do some sample problems. We have 0.73 kilograms equals how many grams? So we have kilo here and we have grams here. All we have to do is move 1, 2, 3 places to get to the gram, which is here. And so basically that tells us that we need to move our decimal 3 places towards the gram, 3 places to the right. So we go 1, 2, 3. That means we got to add a 0 here. So that means this 0, we can exit it out. So the answer would be 730. 730 grams. So we move 1, 2, 3 places to get this answer. We just basically move the decimal. Next we have 5.0 liters equals how many milliliters? Where is liters? Liters are here, our basic unit. And milliliters, milli, is right here. So, can you guess which way we're going to move? That way, because milli is there. So, we write our answer, 5.0. And we have liters here, and we move 1, 2, 3 times to the right. So, 1, 2, 3.
This is where our decimal is going to be. So now it's going to be 5,000. And that would be our answer. Next we have 4.6 centimeters equals how many millimeters? Now we have center, and which is here. And we're going from centimeters to millimeters, which is milli is here. So all we do is we move from here one time. So we take our decimal and we move it one time. So we end up with 46. Now we have 0.12 centimeters equals how many kilometers? So we're starting with centi. Centi is here. Kilo is way over here. So we just basically move right to left. So how many places are we going? Let's see. 1, 2, 3, 4, 5 places to the left. So let's write this and move the decimal 5 places to the left. 1, 2, 3, 4, 5. So this every place will be a 0. So the answer is going to be 1, 2, 3, 4, 5. 5 zeros. 1, 2, 3, 4, 5, 12. So we'll write that again. 1, 2, 3, 4, 5. I'm sorry. That would be the answer. Now we're going to do some sample conversion problems. We're going to convert miles to yards and yards to feet. On the Hesi, I do believe you will be provided the conversion, so you don't have to worry about memorizing it. Don't quote me on that one though. So how you set these problems up, it's pretty simple. You basically go exactly in the order that the problem is written in, and that'll make more sense as I write it out. So first we have miles and yards. So we're going to be focusing on this conversion right here, miles and yards, because there's 1,760 yards in 1 mile. So we'll be focusing on this particular conversion. So now we have 23 miles. So we'll write 23 and 1 mile blank, and that blank is going to be represented by X, and then yards is going to be our 1760. So we just cross multiply and divide by 1. That's 40,480. That'll be the answer. Next we have 29,920 yards equals blank amount of miles. Still focusing on this particular conversion, and we set it up in that order. So we have 29,920 over yards. So we put the 1760 first equals blank. X is going to be our X, miles. So we put 1. So all we do is 29,920 times 1 divided by 1760. That's going to give us 17. Let's go to the next problem. We have 348 feet blank yards. So how many feet are in yards? So now we're dealing with this conversion here. There's 1 yard in 3 feet. So now we're going to set the problem up the same way we did the last one. 348 feet. 3. Because we're dealing with feet and yards now. So that's why we're doing that conversion here. So blank is X. Yards is going to be 1. 116. Next we have 12 miles equals how many yards? So now we're dealing with miles and yards. So we're dealing with this particular conversion here. 12 miles 1 equals blank X over yards, 1760. So now we take our calculator, cross multiply and divide. 21,120. All right. So next we have 37 yards blank feet. So how many yards are in feet? We have 1 yard equals 3 feet. So we just set up our problem. 37 yards 1 equals blank X over feet, 3. So we will do 37 times 3 divided by, which is going to give us 111. Next, we're going to be converting kilograms, pounds, and grams. One thing you want to keep in mind is that when you're converting kilograms to pounds, you multiply by 2.2. And when you're converting pounds to kilograms, you divide by 2.2. When you're going grams to kilograms, you divide by 1,000. And when you're converting kilograms to grams, you multiply by 1,000. Problem number 1, we have 11 kilograms equals how many pounds? So to set this problem up, we do the same order as it's written. 11 kilograms, and how many kilograms is in a pound? 1 equals, that blank represents the unknown number x, and then how many pounds? 2.2, because there's 2.2 pounds and 1 kilogram. So we just cross multiply and divide by 1. 1 is going to give us 24.2 as an answer. We have 55 kilograms equals how many pounds? There's, once again, 2.2 pounds and 1 kilogram. We set our problem up like so. It's 55, let me write it here. 55 kilograms. Kilograms is 1. Unknown number is x. And how many pounds is in the kilograms? 2.2. And then we cross multiply, and it's going to give us 121. Put pounds here. So 121. Next, we have 27 kilograms equals how many pounds? So we'll just do it the same way. Just erase it with my hand. 27 kilograms, 1 kilogram equals blank. It's going to be our x, pounds, 2.2. And then we just cross multiply and divide. 27 times 2.2 divided by 1. It's going to give us 594. That's going to be our answer. All right. Next we have 63,370 grams. Converting that to kilogram. Write our problem up like so. We're dealing with grams and kilograms, so we're going to be focusing on this conversion here. Either you divide by 1,000 or multiply by 1,000, depending on what the question is asking you. So now we're going to grams to kilograms. So if you don't remember like which way you do, you just always set it up like this. Grams, 1,000 equals our unknown, which is x, over kilograms, that's in a gram, which is 1. So we do 63,370 divided by, multiplied by this, divided by 1,000. This is going to give us 63.37. Now we have grams to kilograms. 9,000 grams are how many grams? How many kilograms? So we do 9,000. And how many grams are in a kilogram? 1,000. Equals our unknown over how many kilograms are in grams, which is 1. That's going to give us, we get 9,000 over 1,000, or you can just do it the pattern. 9,000 times 1 divided by 1,000 is going to give us 9. Next we have 8.32 kilograms equals how many grams? We set our problem up like so. How many grams are in kilograms? 1 gram, 1 kilogram, excuse me. And x, and that g, that's our grams, 1,000. And then we do cross multiply and divide. 8,320. Right, next problem. We have 90.71 kilograms equals how many grams? Right, take our 90.71 kilograms over how many kilograms are in grams, which is 1, over x, which is our unknown, and how many grams in kilograms? 1,000. And then we solve, cross multiply, and divide, which will give us 90,710 grams. So now we're going to cover fractions. But before we do, let's go over some rules. When you are subtracting and adding fractions, the denominator must be the same. And if you're multiplying fractions, you can just multiply it straight through. When you're dividing fractions, you need to flip the second fraction or inverse the second fraction and then multiply to get the answer. Let's do some practice problems. Find the least common denominator, and we do that by focusing on the denominator, which is the bottom. First thing we want to do is list the multiplications of 4, and then we're going to list the multiplications of 9. So in this scenario, this is why it's good to know your multiplications and your divisions, like the basic. So the least common denominator in this particular problem would be 45 because they have the 45 in common. Okay, so the next problem, we're going to do the same thing. So we have 12 and 8. You just write down the multiples of 12. You have to write it out like this. It's totally fine. So let's go ahead and do 8, 4. Damn, I don't have to go any further because we have identified the LCD, which is that 24. That's what they have in common. So for this problem, the LCD is going to be 24. So we have some more fraction problems. I did the first two because they're pretty simple. All you have to do is add them across because the denominators are the same. The last problem is 1/2 plus 4/5. The denominator is not the same, so we can't add across. So the first thing we're going to do is try to find our LCD. And I can see that 5 times 2 equals 10, and that is going to be our LCD. This method doesn't always work, so don't try it. Just know that if you do, just be cautious with that. However, I know that I can multiply the first fraction by 5 to get the denominator to be a 10. And then our second fraction, I know I can multiply by 2 to get the 5 to turn into a 10 in our denominator so that we can add this problem straight across. So now we have 1/2 times 5/5, which gives us 5/10. And then we have 4/5 times 2/2, which gives us 8/10. So rewriting our problem, it's going to look like this. 5/10 plus 8/10, which gives us 13/10. Okay, so now we have more problems. 5/7 plus 3/14. First thing we want to do is make sure our denominators are the same. Because they're not, we have to find the LCD to change the problem completely around so that we'll be able to add this fraction up. So without having to write down the multiples of the LCD, define the LCD and all of that stuff, I can see that 2 times 7 makes 14. So because I know that, I know automatically I need to multiply this fraction right here by 2 to get the denominator 14 and 14. All right, let me explain. So we have 5/7. We're going to multiply 2 by 2, and then that's going to give us 10/14. Now that we got this fraction, our new fraction, we can just take this without having to do too much. And now we can add it straight across, and I'll just put a box around this. We got 13/14. That's going to be our answer. Now, depending on the question, they may ask you to reduce.
Next, we have 7/1/8 plus 2 4/12. Now, the first thing you need to ask yourself, are our denominators the same? In this case, they are not. Now, as far as the whole numbers, we're just going to leave that right now. We're not going to solve this like this is a mixed fraction. I remember when I first started encountered these problems, I wanted to solve it like it was a mixed fraction, but that's incorrect. So you have to find your LCD. And once you find your LCD, you're going to go ahead and add those whole numbers together. Only when you have your LCD, of course. So here I am just writing out the multiples of 8, and I'm going to write out the multiples of 12 to try to find the LCD. And in this case, I found the LCD, and the LCD is going to be 24. So the first fraction, excluding the whole number, I am going to multiply by 3 to get the denominator to be a 24. And the second fraction, I am going to multiply by 2 to get my denominator to turn into 24. And then that way, we'll be able to add. So that leaves us with 7, 3 over 24, plus 2, 8 over 24. Now when we add this up, we're going to do 7 plus 2, which is going to give us 9. And then we do 3 over 24 plus 8 over 24, which is going to give us 11 over 24. Next, we have 3 over 20 minus 2 over 20. Because our denominators are the same, we can just subtract straight across. And that's going to leave us with 1 over 20 as the final
and now
answer.
We have some more subtraction fractions. We do these pretty much the same way we do addition, but we subtract. So now we have 28 minus 17. So simply all we would do is subtract 28 from 17. We can do this the old school way by literally writing it out. 8 minus 7 is 1. 2 minus 1 is 1. So we have 11 over 37 will be our problem, or be the answer. Next we have 17 over 25 minus 3 over 5. So we'll do this the same way we do any other problem. We will have to make sure that the denominator is the same. I've said it enough during this video, but it's so important to make sure that the denominators are the same before you add or subtract your 5. So we're going to use 5, right, to multiply this fraction to get 25 so that we can subtract. It's going to give us 15 over 5. So now 17 minus 15 over, 25. So let's rewrite the problem. This is why I write stuff down, because I'll be forgetting digits and it's just not cool. 17 over 25 minus our new fraction, 15 over 25. And that's going to give us 2 over 25. And they may ask you to reduce it, and you basically, or write it in a mixed fraction or whatever. So you do long division to write it in a mixed
Next,
fraction.
we have 1/9 over 10 minus 1/5. First thing we want to do is make sure our denominators are the same, and they're not. And because they are not, we have to find LCD. And in this case, we see that we can multiply 5 times 2 to get 10, or 10 divided by 5 will be 2. So we have to multiply that second fraction by 2. So we'll do 1 over 5 times 2 over 2 to give us 2 over 10 so that we can completely solve the problem. So let's rewrite our problem. 1/9 over 10 minus our new fraction 2 over 10. And that's going to give us, so 9 minus 2 is 7. And that'll be over 10, plus that 1 will be in the front. And that'll be our final answer. Next, we have 25, 1 over 7 minus 12, 5 over 7. First thing we're going to do when we're dealing with addition and subtraction problems is ask ourselves, are our denominators the same? Are they? Yes, they are in this case. So we're good to go, right? No, we're not good to go. Because if we were to solve this problem, even though the denominators are the same, we'll end up with a negative number, and we do not want a negative fraction or a negative number in this case. So this is what happens when we're doing subtraction. Sometimes we're going to add and borrow what they call borrow a 1. So we're going to borrow a 1 from that 25. And that 25 is going to become 24. And that 1 is going to look like 7 over 7, because if you were to plug in 7 divided by 7 in the calculator, you're going to get a 1. So that's how our 1 is going to look like in this case, 7 over 7. So we're going to add that 7 over 7 plus 1 over 7. And that's going to give us 24, 8 over 7. So now we can solve our problem.
So now we just go ahead and subtract because our denominators are the same. So we got 24 minus 24 is 12, and then 8 minus 5 is going to give us 3/7. That's your answer. All right, so if you didn't get that, I'll do it again with this problem. But let's go to a word problem. So next we have a word problem. Alan is making a table. The table will be 6½ feet long and 4 feet wide. The board for the table is 7⅛ feet long and 4 feet wide. How much of the board will Alan need to cut off? So the first thing that comes to my mind when I hear or see the word cut off, that would be subtraction. So I'm going to pay attention to 7⅛ and 6⅛. Now, so you just basically would set it up like you would set up any other subtraction fraction problem. And that's pretty much how we're gonna solve it. So first thing we need to do is find the LCD. But since I know 4 times 2 equals 8, I can just go ahead and multiply this fraction by 4 to give us a new fraction so that we can solve the problem. That's gonna give us 1/3/8, and that is the answer. Okay, next we have 5/2 minus 3/4. So, like any other fraction, we ask a fraction problem. We ask ourselves, are the denominators the same when we're dealing with a subtraction or addition problem? Once again, so they're not the same. So we'll have to just go ahead and find the LCD between 3 and 5, which is going to be 15, and we just basically change our denominators into 15, and we do that by multiplying this fraction by 5, which is going to give us 15 here. This fraction by 3, which is going to give us 15 in our denominator. And let's rewrite the problem, shall we? Now we have 5, our new problems right here. Just in case you can't see that. 5/10/15 minus 3/12/15. Are we done? We're not done because we can't subtract 10 from 12. It'll leave us with a negative number, just how we had the same instance with this particular problem. We're going to have to add a 1 and borrow from that 5 so that this number can become higher so we can subtract it without any negative numbers. Let's get started with that. So to do that, we'll just have to rewrite this problem. Take the 5, that turns into 4, and then we add our 1, which is going to be 15/15. Whatever your denominator is, that's going to be your 1. So we add 15/15. Just like in this problem, we added 7/7 to get that 1. Same thing. So this is 15/15. I know it doesn't look like it, but so we get 25. 10 plus 15 is 25/15. That's our new fraction for this particular part of the problem. And so now we can go ahead and subtract. So now we ended up with this right here. Subtract this right here from this. So I hope you guys still can see this. This is really small. Okay, so let's do it. 4/25/15 minus 3/12/15. I don't know if I can see that, but this is what we end up with right here. So once we do that, we end up with 1/25 minus 12 is going to give us 13/15. That is the final answer. So we have 4/5 divided by 1/7. Now I'm just going to rewrite the problem so that I can end up with the correct answer. Instead of dividing when you're doing a inverse, you're going to multiply so that you can end up with the correct answer. So 4 times 7 is 28. And then 5 times 1 is 5. Now we can't leave the problem like this. We'll have to use long division to get rid of this improper fraction. And we'll do this like this. We won't have space, so I'll just erase that right there. So 5 can go into 28 about 5 times. 5 times 5 is 25. And remember, this is what we're going to do: divide, multiply, subtract, and bring down. Those are the steps you take when you're doing long division. And I will be giving you guys that along this whole entire video. Okay, so anyway, we are going to subtract now. 8 from 5 is 3. And then there's nothing else to bring down. So our answer is going to be, it's going to be 5, 3 over 5. So that'll be our answer right here. All right, so I'm going to erase this so that we can move on to the next problem. Okay, next we have 12 over 15 divided by 3 over 5. Now, keep in mind our rules. I'm going ahead and do the same thing we did to the last problem. Rewrite the problem. Like I said, there's like so many ways to do this, y'all, but this is my way, and it is a correct way, and also the way the book teaches you how to do it. So 12 times 5 is 60, and 15 times 3, I think is 70. No, it's not 75. It's 45. So what you do is, we don't leave it like this, of course. We'll just go ahead and use long division. 45 divided by 60. So that 45 can go into 60 one time. And keep in mind our steps: divide, multiply, subtract, bring down when we're doing long division. One time it can go in there. So now we have, let's see, 10. It's going to be 5. We got 5 here. Then we got 5 from 4 is 1. So the answer is going to be, so next we have 12 over 15 divided by 3 over 5. So we start by rewriting the problem. 5 over 3. And that's going to give us 60 over 45. And we don't leave it like that, of course. The problem, we have to assume that it's going to ask us to like reduce it to the lowest common denominator. In this case, we'll just go ahead and do 45 divided by 60. And we want to keep in mind our steps, and that's divide for D, multiply for M, S for subtract, and B for bring down. That's how you do like the simple division problem. 45 can go into 60 one time, and then so 1 times 45 is 45, and then we subtract. There's nothing else to bring down, which lets me know that our problem is at its end. And so we just follow from here. So 10 minus 5 is going to give us 5, and we borrowed that 1 from the 6, so that turns into 5, and that 5 minus 4 is going to give us 1, so it's going to be 15. So now we have to rewrite the problem. So we rewrite it as 45 over 15, and then 1 is going to be the whole number. So I'm gonna make a video, a separate video about like where to put what, because that confused me sometimes. So anyway, you put your denominator here, the whole number makes it the whole number, the 15, the numerator. So numerator, denominator, whole number, numerator. All right, so can we keep our problem like this? If you don't see it as an option, that means you have to reduce this even further. So in this case, we have to reduce this 15 over 45 a little bit further. So I'm going to erase this, y'all, so that it'll have some space. And I can erase all of this too. That's our answer. We have to reduce that answer to show you guys. Let's write it over here. Okay, so to reduce 15 over 45, you have to like divide by the GFC, the greatest common factor. So the greatest number I can see that both of these 15 and 45 have in common is 5. So you just divide by 5. And that's going to give you 15 divided by 5 is 3. And then 45 divided by 5 is 9. So you end up with 3/9. And it can be reduced even more so. So we do that by dividing like what number can go into 9 and also 3. So that'll be 3. So we just divide 3 by 3 and 9 by 3. And that's going to give us 1/3. So the final answer will be 1/3. Okay, next we have 10 divided by 3/1/3. So first thing we want to do is add a 1 under this. And we need to get rid of this mixed fraction. And we do that by 3 times 3 equals 9 plus 1 gives us 10/3. So I'll just write that out. 3 times 3 gives us 9. 9 plus 1 gives us 10. And so we keep our same denominator. And so we rewrite our problem as 10/3. So now I'll just write the problem over as follows. We got 10/1 divided by 10/3 now. So once we flip the second or inverse the second fraction, we'll get 10/1 times 3/10. That's going to give us 30/10, and 30 divided by 10 is 3. So our final answer is 3. Next, we have 12/1/3 divided by 2. So first thing I'm going to do is go ahead and put that imaginary 1 there. And we pretty much do this problem like we do this problem here. So we got to make sure we do this right. We can go ahead and get rid of the mixed fraction by adding 12 times 3. 12 times 3 plus 1 is 36. 36 plus 1 gives us 37. So we'll have 37/3. So we got 2/1, but since we're trying to inverse it, so we just multiply 1/2. And 37/6, and then we'll just do 6 divided by 30. 6 can go into 37 6 times. 6 times 6 is 36. That gives us a remainder of 1. So our denominator stays the same number. So it's going to be 6. We got 1/6. That's going to be our final answer.
Now we have multiplication fractions. We have 3/5 times 2/3.
We can just go ahead and multiply straight across because remember our rules, right? 3 times 2 is 6. 5 times 3 is 15. Now, you may get instructions that say reduce to the lowest term, to the lowest value. So you'll just reduce this, and we reduce by finding a common number between 6 and 15. And I have one, and that's going to be 3. Because 3 times 2 is 6, and 3 times 5 is 15. So we'll just divide by 3. And that's going to give us 2/5. Now, if you don't see this value right here as an option, I advise you to go ahead and just take the 16 divided by 15 and just like divide it this way, because it's going to really depend on ultimately what they're asking for and what your options are. So this is an option of your answer. So we can do 6 divided by 15. So 6 goes into 15. Let's see, 3, no, not 3 times. It's going to be 2 times to 6 times. 6 times 2 is 12. That's going to give us 3 as a remainder. So this also could be an option. So this also can be an option for your answer. We have the next problem. 7/9 times 1/9. So we can just do this problem by simply multiplying across. 7 times 1 is 7. 9 times 9 is 81. Depending on the instructions, they may ask you to reduce it or turn it into a fraction, a mixed fraction, but just pay attention to your instructions. But this is our answer. So next we have 6 times 4/5. So we do this problem like we did the last few problems with division. We add that 1. So I'm gonna write this problem over. So we have 6 times 4, gonna give us 24. And then we have 5 times 1, it's gonna give us 5. And then so we'll just we just go ahead and, depends on, like I said, what they're asking for. So 5 goes into 24 4 times. 4 times 5 is 20. And then 24 minus 20 is gonna give us 4. 4 gonna be 4/5. Next we have 3/1/3 times 2. And we do this problem like we did this one. We add that imaginary 1 to help us visualize it better and help us to rewrite the problem. To me, I think the multiplication and the division fractions are easier than the subtraction and addition, because it's like you have to find the LCD, and I don't know, just me personally. But mixed fraction here, we can get rid of that mixed fraction by multiplying 3 times 3 and then adding that 1. It's going to give us 10/3. So I'll just write that out. 3 times 3 is 9, and then 9 plus 1 is 10. That's where we get the 10 from, and we keep our same denominator. So we have 10/3. So we're going to scratch that out. And then we have times 2/1. Let's just move all of this out of the way, right? Let's focus right here. So 10 times 2 is 20. And then 3 times 1 is 3. Once again, this might be your final answer. Depends on, well, this is improper, so it's probably not going to be your answer. But it depends on some factors. So we're just going to go ahead and do division to find a better looking fraction than this one. 3 goes into 20. Let's see. 6 times? Yeah, 6 times. 6 times 3 is 18. And then 18 from 20 is going to be 2. And then it's going to be our fraction. And we rewrite that as 6, our whole number, 3, our denominator, and 2, our numerator. Alright guys, so next you'll see a lot of problems that ask you to change fractions into decimals. You can do this several ways. You can do it the long way or the easier way. And all you have to do is simply just type in 3 divided by 4 in your calculator, and it's going to give you the decimal. Or you can do long division, which I'm going to show you guys in a few seconds. Okay, so this is the harder way to do to change the fractions into decimals. You would just do 4 divided by 3, and because you can't divide 4 by 3 and 3 by 4, you would have to add a 0, a decimal point, and a 0. So we can look at this number as 30. All right, so 4 goes into 30 how many times? So it'll be 7 times. 7 times. Don't forget to move your decimal point up. So 7 times 4 is 28, and we subtract. And so once we subtract this 8, it's gonna give us 2. And so because we have a remainder, we have to add another 0, because the whole goal is to not have any remainders when we're dealing with these types of problems. So add a 0, and we're gonna bring it down. So now we have 20. So remember, our steps: divide, multiply, subtract, and bring down when we're doing long division. But anyway, So now we brought it down. Now we're gonna divide 20 and 5, which is gonna give us, let's see, 4 times. We're gonna give 6. So 6, nope, that's not gonna work. We're gonna do 5. 5. So no, I did 20 divided by 4 is 5. And then 5 times 4 is going to give us 20. And that's going to give us 0. That's what we're looking for. So the answer would be 0.75. All right, so now we have 5/8. And also to check it, you guys can, like I said, you can put it in your calculator. That's easier, it's faster. 3/4, and it's going to give you 0.75. But this is just a longer way of doing both ways, just in case technology fails you somehow. All right, so let's do 5/8. We do it the same way. And since we're done with this problem, I'll just go ahead and erase it so I can have it home. All right, so let's continue with 5/8. So like we did with the last problem, we're going to go ahead and plug our numbers in. 5/8. Now because 8 can't go into 5, we add a decimal point and a 0. So we look at this number now as 50. So how many times 8 can go into 50? It goes into 50 about 6 times. And we're going to add our point and just make sure we line it up. So it goes into 8 50 times, and let's keep in mind our steps. Now that we did that, we're going to multiply. 8 times 6 is going to give us 48. And then we subtract. That's going to give us 2. And so our whole goal is to get rid of any remainders we have. So because we can't go any further unless we get rid of this 2, we have to add another 0 on that 0. And that leaves us with 20. So 20 goes into 8 about 4. No, not 4 times. 20 goes into 8 2 times. And so 2 times 8 is going to give us 16. And then 20 minus 16 is going to give us 4. And so we still have a remainder. So we have to just add another 0. Bring that 0 down. That gives us 40. So 40 divided by 8 is going to give us 5. And then 5 times 8 is 40. And then now we have our zeros. So now we're finished. So 5/8 is 0.625. All right, 2/3. So we do this like we did the last problem. We set it up like so. So there's no way 3 can go into 2. So we have to add a decimal point and a 0. So now we can look at this number as a whole number, 20. So how many times 3 can go into 20? About 6 times. Because 6 times, let me show you, put it right here. 6 times 3 is going to be 18. And so if we subtract 20 from 18, that's going to give us 2. So we don't want remainders once again. So we have to add another 0. And then we bring the 0 down. So we have a 0 here. So we have 20. So now we have 20 divided by 3. That's going to be 6 again. So we add another 6 here. And then 6 times 3 is going to give us 18. And so we're going to be stuck with the same 2, okay? So we have 2. So we're going to add another 0. Bring that down. So basically, I'm going to stop here. It's going to give us the same values, y'all. It's going to be 6.666666666. So, yeah, we'll just leave it like that. Some fractions are like that. So, with that being said, it's good to know the ones. Well, I'll show you guys in a little bit. Some factors. You'll see some factors on the screen that you might want to screenshot. It's good to just like memorize some of them, or it's good to just use the calculator. Yeah. So in this case, we'll write this answer like 6.666, you know, or we can write it like this, or just 6 point with the bar on the top of it, indicating that the number keeps repeating. So, all right, y'all. So now we're gonna change decimals into fractions. There's no easy way to do this. Like we can change our fractions to our decimals. There's no easy way. So we do this by knowing our place values and also dividing. For an example, 0.02, we would basically find the placement value of the last digit, which is ones, tens, hundreds. It's going to be in the hundreds. So that tells us I need to divide by 100 to get the decimal to turn into a fraction. So I would take 2 and I would divide it by 100. And so we don't keep it like this in this form. We'll just reduce it. And a common number I can see between 2 and 100 will be 2. So we will go ahead and divide this problem by 2. And that's going to give us 1 over 50. And that'll be your final answer. So 0.9. This is in a 1 tenths place. So we will divide 9 over 10. That's pretty much the answer. There's something else you can do with that. Next, we have 0.08 in the ones, tens, hundreds place. We'll just take our 8 and we'll put it over 100. Now, we need to reduce this problem. And a common number I can see 2. I can see 2 in this. So we're going to divide it by 2. 8 divided by 2 is 4 over 50. So now we can reduce 4 and 50 by 2 again. And that's going to give us 2 over 25. And that'll be your final answer. Next we have 3.055. And we have it in a thousands place. 1, tens, hundred, thousands. So we divide by 1,000. Now, because this number is before the decimal place, it's going to be our whole number, right? So we do the 55 over 1,000 because once again, last digit is in the thousands place. And then 3 comes from here. It sits outside of the decimal point. That's why it goes there. But they may ask you to reduce. So you probably can reduce a little bit more by finding a common factor. So it's probably going to be 5. I have to reduce this right here by 5. It will give me 11 over 200, and that would not be your final answer, because your final answer would be 11, 3 over 200. All right, so now we have 3.48. So we'll do that the same way. This is a 200 right there. Right, so our 3, because it's before the decimal, we go ahead and make that our whole number. 1s, 10s, hundreds, so we're going to divide by 100, 48 by 100. And we get started, we can reduce this down. I can see, I can see 2. Let's divide it by, let's divide by 2. To reduce this a little bit further. 48 divided by 2 is going to give this 24. And 100 divided by 2 is 50. We can reduce that a little bit more by 2. Once again, and it's going to give us 12. And 50 divided by 2 is 25. And so 12 over 25 is the final answer.
So you will be asked on the Hesi to change fractions into ratios. You won't get a lot of problems, but you will get a few. And you do this by simply adding a colon in between your numerator and your denominator. So I'll do that again with 19 over 40. You just place 19 first, you place your colon second, and then your 40, your denominator, lastly. So what if you had a number like this, 23 over 7 equals x over 3? How would you write that? Well, you would write your 23 first, colon, 7. You would write 2 colons, which is equivalent to the equal sign, with your x, a colon, and then 3. Very simple. Let's do some practice problems.
Next, we're going to do ratios and proportions. So let's get started. So with these type of problems, you just basically need to set them up like a division problem. So the question asks us to solve the proportion to find the value of x. So this looks kind of foreign, I know, but basically you just set it up like it's a fraction. and that means equal, and the 2 dots just means a fraction bar. So just think about it like that. So to solve this problem, I'll be using my calculator instead of doing it the old-fashioned way. So you'll just cross multiply and divide. So we'll just do 10 times 14 divided by 7. 10 times 14, and then 140 divided by 7. Gonna give us 20. So x equals 20. So basically you cross multiply and you just divide by 7, and that's gonna give you that. Next problem, y'all can follow along with me if you have your calculators. 7 over 5 equals 91 over x. So we do this the same way. We multiply 91 times 5 divided by 7. $455, and then 455 divided by 7. Is 65, so x equals 65. 15, x, 3, and 8. Let's just do it. 15 over x equals 3 over 8. We cross multiply and divide by 3. Gives us 40. So x equals 40. We have John buys 3 bags of chips for $4.50. How much would it cost for John to buy 5 bags of chips? So first thing I'll do is underline any numbers I see in the paragraph or the sentence. So that's it. Yep. So I'll just set this problem up just like how I would set up any other proportion or ratio problem, and I will just put this in a fraction form and in that order too. And goes 5 will go here, and we'll put x at the bottom because that's the unknown value. So we'll just basically cross multiply 450 times 5 to 22.5. So we have 22.5 divided by 3, which gives us 7.5. So it'll cost John $7.50 to buy the 5 bags of chips. Now there's other ways that you can do this problem. You got another way to do this problem, but I prefer the first way. But anyway, so John bought 3 bags for $4.50. So find out how much one bag would cost. So I would just basically divide 450 by 3 to find out how much individual bag costs, which is going to be $1.50. So if I know that one bag costs $1.50, I would just take $1.50 and multiply that by 5. That's going to give you $7.50. So either or. So the questions on the Hesi will ask you to change the decimal or change the fraction into a percentage. And this is very easy, so I'll just show you guys. When you're moving the decimal places, you always move it 2 places to the right. So 1, 2, that's gonna be 13%. You also can find it this way. You can just type in a calculator 0.13 times 100, and it's gonna give you 13. So 13% is the answer. And make sure it has the percentage that indicates it's a percentage. Next we have 0.002. The same way. You move the decimal place 2 places to the right. So we go 1, 2. So we have 0.2 or 0.2. And you can easily find out this. To see if it's correct, you can just type in a calculator 0.002 times 100, and it's going to give you 0.2%. Okay, So now we have the fractions. 9 over 10. How do we convert that to the percentages? We just type in the calculator. Well, it's two ways to do that. We can type in our calculators 9 divided by 10 times 100. That's going to give you 90. So I'll just write that out. 9 divided by 10 times 100, which will give you 90%. So let's do 5 over 6 times 100, which will give us 83.3333%. So as you can see, the pattern will repeat itself. It will be 8.333333. So we'll just take the first 3 digits and multiply that by 100, and that will give you 83%. Okay, so when you run across questions like this, it's important to pay attention to what the question is asking you, because how it's worded is going to depend on how you're going to set it up, and that's going to make sense in a little bit. So for example, we have the first question that says, what is 15 out of 75? So the wording says out of. So this is how you set up an out of type of problem. You do 15 out of 75 equals x over 100. So we do 100 times 15. It's going to give us 1500 divided by 75, which is going to give us 20. So the answer is going to be 20%. So once again, 100 times 15 divided by 75. Okay, so this question says, what is 2 out of 50? Out of, another out of, as a percentage. So that means you just have to write it in that type of form, in a percentage form. So it's going to be the same situation. 2 out of 50, x, the unknown number, over 100, because when we're dealing with percentages, always think about 100, always. So you would do 2 times 100, which is 200 divided by 50. So let's do that. So the answer is going to be 4%. Okay. So now we're going to be doing a of problem. Get some different color. So a of problem, you solve those, you just set it up differently. So the question says, what is 28 of 100? So this is how you set up an of problem. You put your x first, the second number, which is 100%, and then you do your first given number, which is 28. You put that at the top, over 100. So it's going to be 28 times 100 divided by 100. 28 Okay, so that's an of problem. So we have another of problem. So what is 15.5 of 600? So we use the same formula. You put x here over your second given number. Because I'm telling you, y'all, if y'all don't follow the formula that I gave y'all, it can be really disastrous. So x over 600, all right, over the first given number, which is 15.5. It took me a little minute to figure this out. So I got it, and I gave you guys a shortcut. So all we have to do now, since we know how to properly set the problem up, is 600 times 15.5 divided by 100, 93. Lucky y'all, I'll get the formula, the cheat code. Anyway, so let's go to the, I like to call the of what number problem. Of what number problem. So this is how you set up these type of problems. You put your first given number, which is the 65, over x, And then your second given number, which is the 25 over 100. So it seems like it's a pattern here, right? Where the 100 is always the second fraction at the second fraction denominator. So just remember that. All right. So you just cross multiply 65 times 100. 65 times 100 divided by 25. 260. So let's do another one. So like the formula says, the of what number question, you get your first given number, which is 44 over x over your second given number over 100. That's going to give us 176.
Now we will be covering algebra. So let's go over some basic rules first. We want to keep in mind our order of operations, and to do so, we have a mnemonic. Please excuse my dear Aunt Sally that students use to help them remember the order of operations. First, we have parentheses, exponents, multiplication and division, addition and subtraction. So this basically tells you what order of operation you should do first when you encounter an expression. Now we'll go over integer rules. For the sake of keeping this video short, we'll just touch on the multiplication and division rules. If you are multiplying or dividing by two positive numbers, you end up with a positive number. If you're multiplying or dividing a negative number and a negative number, you end up with a positive number. Now, if you're multiplying or dividing a positive number and a negative number, you'll end up with a negative number. Something to keep in mind when dealing with algebra expressions is that when you're dividing, you subtract your exponents, and when you're multiplying, you add them.
First, we have 2x to the fourth, y to the third, and z divided by x, 8x to the second, and z to the second. First thing we do is 2 divided by 8, which is going to give us 4. And we have x to the fourth divided by x to the second. And remember, we're not dividing, we're subtracting. So 4 from 2 is going to give us what? 2. X to the second. And that x goes on top in the numerator's place because this 4 here is greater. Same reason why the 4 is at the bottom in the denominator's place, because the 8 is greater than 2. But if it was vice versa, then the 4 would be in the numerator's place. So now we have y to the third, and there's no y to divide it by, so we just leave it on top where it originally is. And now we have z divided by z to the second power. So 2 minus 1 is going to give us 1. And remember, there's a 1 or imaginary 1 there. When there's no exponents, just imagine a 1 there. So 2 from 1 is going to give us 1. And can you guys guess where the z is going to go? If you guess the bottom, you're right, because 2 is greater than 1. This is going to give us our final answer. Next, we have 2x to the fifth y times 4x to the third y 4 to the fourth. So first thing we do is multiply. 2 times 4 going to give us 8. Now we have x to the fifth and x to the third. So we're adding because this is a multiplication problem. So we have x to the 8. Then we have y and y to the fourth. This is an imaginary 1 here, remember? So 4 plus 1 is 5. We have y to the fifth. You'll be asked on the Hesi to simplify questions that are similar to these. Next we have negative k minus 4 equals negative 21. Now the whole goal is, when you see these type of problems, is to isolate your variable. And you do that by eliminating. So first we have a negative 4. We'll go ahead and add 4 to both sides. I'm going to cancel out the negative 4 here. We have negative k, negative k equals, so 21, a negative 21 plus 4 is 17, so it's going to equal negative 17. So now we're left with the k right here. So this is a multiplication. 7 times k, so we'll have to divide each side by -7 to get rid of the 7 so that the k can be on this side of the equal sign by itself. So that's going to leave us canceling out the -7s, and we're left with k. And k will equal, because a negative divided by a negative, or a negative times a negative, will be a positive. So it'll leave us just with 17 over 7. A positive 17 over 7. Next we have a negative xy times x minus y plus y. So the first thing we're going to do is plug in our variables, substitutions, and I have to always write it out because we're forgetting, and I don't want to miss a step just because I didn't write something out. So word of advice, always write it out on your scratch paper. Y is -2. I'll write it above. So with that being said, we're going to have to rewrite this problem and plug in our numbers here. So we have -4 times -2, and we have 4 minus -2 plus -2. Alright, so according to the order of operations, we do what's in the parentheses first. So that's this here. So we got a 4 minus a -2. It's going to give us 6. And so the next step we'll take is go ahead and do the multiplication according to our order of operations. So a -2 times a -2 will give us a positive 8. And then we just bring down our -2 here. So the next thing we do, I know that looks weird, but we multiply 8 and 6, which is going to give us 48, plus that -2. So positive 48 plus a -2 will give us 46, and that will be our final answer. The first question asks us to evaluate, and as you can see, we're giving some values so that we can substitute our variables for these numbers here. So basically you just plug them in and you just solve the problem. So for example, 2x, so the x is going to be 2, so I'll just rewrite the problem. And when I'm doing problems like this, I rewrite the problem, because if not, I probably will mess the problem up. So our new x is going to be 2. That's going to be plus 6. And our y is going to be 4. Multiply that by 4. And then we have 3 for our 3, -3. And then we'll just substitute that right out of the colors here. That z is going to be -3. So now we just basically solve the problem like a regular algebra expression. I would say algebra was about 25% of the Hesi math portion. I would say so. So keep it in mind. Please excuse my dear Aunt Sally, those particular steps. We'll go ahead and solve the problem. I don't really have a lot of space for this, but we're just going to have to erase and make some space. Just in case I got to write something at the bottom. Alright, for now, we'll just keep it like. Okay, so first we do according to our steps. Please excuse my dear Aunt Sally. And if you have to write stuff down, go ahead and write it down, because it's better to write it down than to forget a step just because you think you know. So we're going to go ahead and do the parenthesis problems. 2 times 2 is 4. So we'll just go ahead and rewrite the problem right here. So we'll put 4 plus, now we got 6 times 4. That's going to give us 24. You're going to do minus, there's a negative. However, when we take 3 times 3, a negative plus a negative, it equals a positive. So it's going to be a positive 9. And now, according to our rules, we can go ahead and add these up. These 7. And that's going to be our final answer. That's all you do for that. Simplify the expression. So we have 3x to the 4th power, y to the 2nd power, z times 2y to the 4th power times z to the 5th power. The first thing I do, or what I need to do in this type of problem, is to write out how many exponents I have of each variable. And I do that by simply adding up the exponents. So for my x's, I only have 4 x's. I'll just write 4 here. My y's, I have 2 here, and then I have 4 here. So we have 6 y's. My z's, I have 1 z here, and I have 5 z's here. So I have collectively 6 z's. This is going to help me write my problem and make sure I don't miss anything, because if I don't write it out, I don't know if y'all like me, I just can't do math in my head. I have to write it out, because if I can see it, I know I can pick the right answer. So 3 times 2 is 6. And then we have x. How many x's do we have? We have, so y's, how many y's do we have? We have 2, that's 4, we have 6. So we get this x, y. And then z's, we have 6 z's. And this will be your final answer. Next, we have a problem where we can use the fall method, and I'll show you guys what that is if you don't know. So the acronym for fall stands for first, outer, inner, and last. So I'll go ahead and show you guys an example of it. So the first thing we're going to do is multiply 5 by 3x, 5x by 3x, and that's going to give us 15x, and then 15x squared, I'm sorry, because there's 2 x's, and then 5 times 3, which is going to give us positive plus 15x, and then we'll do the same thing with the 2. 2 times 3 is 3x, and then 2 times regular 3 is just positive 6. So we can combine like terms with the 15x and this, and there's supposed to be a plus there. But we go ahead and combine that, and then we'll end up with 15x squared plus 21x plus 6. And then be the final answer.
Military time. On the Hesi, you will be asked to convert military time into regular time and regular time into military time. All of our AM times are written in blue, and all of our PM times are written in red. One thing you want to keep in mind for is identifying your morning times is that there will be a 0 in front of the regular time. So for 4 o'clock in the morning, it would be written 0400. For 9 o'clock in the morning, it would be written 0900. Now for 10 o'clock in the morning, it will just be written 1000. And for 11, it'll be 1100. And 12 a.m. in the morning would be 2400 or 0000. Now, indicating your military evening times is easy. All you have to do is subtract. If you're being asked to identify what is 1600, you just subtract 1600 from 12. If they ask you what is 2100, all you have to do is subtract 2100 from 12, and that's going to give you 900. So let's do some example problems.
The question asks, convert the following 12-hour clock times to military times. So I wanted to show you guys one and also question number 4, because I think the hardest thing about learning military time is knowing the 12 a.m. difference from the 12 p.m. So I'll give you guys an opportunity with keeping in mind the military time for number 1. So 12 AM and military time, if you guessed right, would be 2400 or 000. And then number 4, 12 p.m. would be 1200. I don't know why that was hard for me to grasp. And I'm going over this because I do remember seeing a problem regarding 12 p.m. and 12 a.m. I just can't remember which one it was, but it's on there. So know the difference between 12 a.m. military time versus 12 p.m. Now we have number 2. We have 11:19 and 46 seconds a.m. Don't worry about the seconds, y'all. It's just what got in the book. That's how I had it in the book. So how do you do that time? I'll give you guys an opportunity to convert it. So in military time, in the morning, it'll be the 0 on the front, right? But because it's a double digit, we don't put the 0, and we just go ahead and just write it out as, and with no colons, of course. All right, number 3 is 2:22 in the morning. So what is the time for 2:22 military time? All right, if you guessed 0222, you're correct. Next question asks us, convert the following military times to 12-hour clock times. All right, first one we have is 0603, not 0600. So that would be, I'll give you guys a few seconds to answer it on your own. That will be, because at 0, it tells us that it's in the morning. All right, 6:03 in the morning. Next we have 1200. So how do we do that? Well, the answer's obviously already on the board. So 1200 military time will be 12 p.m. regular time. Next we have 2111. So I'll give you guys a few seconds to answer that one, keeping in mind our military time. And if you guessed 9:11, was it going to be PM or AM? PM, because remember, morning it would be 0900 if that was the case. So yeah, that's pretty much it for military time. If you guys have any questions, make sure you comment down.
All right, y'all, that is pretty much it. I wish you guys well on your Hesi exams or your T's or Kaplan, whatever exam you're taking. I want to give a quick shout out to all of my new subscribers and everybody who has been leaving comments, leaving their testimonies of how these videos has helped them pass the Hesi. Please subscribe if you have not already, and I will see you guys on the next one.